So the idea of breadth first search is that you start with some nodes, okay, like this guy, 0 guy, and then every node that is adjacent to this node is going to be visited, okay. So we look at all the adjacent node to this particular guy, and we're going to see so we look at this guy. So let me mark it with green, and we see what are the nodes that are adjacent to this vertex or this node. So it's going to be this one and 2. Okay, 1 and 2. Okay, so that would be the first layer, the next layer of the breadth first search, like that. So we're gonna call this layer 0, and this is layer 1. Okay, and then we'll look at we'll go to all the nodes in layer 1 to figure out what's the next layer. Okay, so what are the nodes that are adjacent to 1? Okay, so now I'm gonna go over nodes in layer 1 one by one. Okay, let's go over to that. So I mark it as green. Okay, it's adjacent to 4, right? So 4 is gonna be, now 4 is seen. I would put 4 into the next layer. Okay, so it's gonna be layer 2, but I'm only see 4 for now, right? Now I'm gonna go look at 2, and 2 is adjacent to 0 and 1, right? But both these nodes are already seen. Okay, so it already has a layer number, right? But the new nodes are 3 and 7. Okay, so these 3 nodes that I've seen during my visit to layer 1 nodes is going to be put into layer 2. So this is called layer 2. Okay, and so on. Now I would look at the nodes in layer 2, right? And then I would figure out the nodes in layer 3, which are this. Okay, so but the way I do it is that I start looking at 4, right? And then 4 would see 8 and 6. Okay, I put them into layer 3. Now I look at 3, there's nothing new. I look at 7, I see 5, so I put 5 in layer 3, and then I keep doing that. Okay, so it will go one layer by layer, and then it will see more and more nodes. The goal of this breadth first search is to look at all the nodes that are reachable from the starting node. We usually refer to this as a source. Okay, and as you may guess, the number of the layers represent the length of the shortest path from the source to that particular vertex. Like if you start with the source, right, you see everything that are adjacent to that will be layer 1, right? And then everything that are adjacent to this guy will be layer 2. So the shortest path, I mean the number of edges from that vertex to the source is going to be 2. And then the third layer, like that. Okay, the shortest path will be of length 3. Okay, so the number of in the layer represent the number of edges, the minimum number of edges in the shortest path from particular vertex to the source. Okay, now if you do this, you stop at layer 3 in this example. Now there are some leftover here. If you want to count the number of connected components, that's the goal for the task, the connected component task. You need to you need to run breadth first search again, right? But you've seen that all these vertices has already been visited or dealt with. Okay, at the end you look at 8 and 6 and 5, right? So now we need to start at some other vertex nodes that we haven't seen so far. So we probably go to maybe 10, and then we'll visit that. So if we start with this, the layer will be 10, 9, 11. So this will be layer 0, 1, and 2. And if you start with 12, this will be layer 0, and this will be layer 1. But that's different calls to breadth first search. Okay, if you call breadth first search 3 times, then the number of connected component is 3. Okay, but you need to make sure you don't call you don't start breadth first search on the same connected component twice, right? Okay, so you can do that using the variables that we keep in when we do breadth first search. Now, so let's look at let's write some code. So basically, I'm gonna keep. There are many ways to write a shorter breadth first search, but for now, let's write the most explicit one. When you're good with that, then we can write a shorter one later on. Okay, okay. But please make sure when you write your code, you don't just copy and paste my code, right? You should try to write your own, and then if you find some bug, you can just look at my code instead. Okay, so you understand breadth first search pretty clearly. Okay, so I need to do some bookkeeping. Okay, when I would basically call breadth first search 0, so that to do the breadth first search starting from the vertex 0. Okay, now I need to keep the layer for each vertex, and I also need to make sure that I keep track of the vertex, the nodes that I have seen when I look at one particular vertex. Okay, like when I work on this vertex, I want to really make sure that I see this vertex as the new one, something like that. So I would basically keep two things. One is layer, variable layer. So that's the layer number of the node. And then I also have this for each vertex. Okay, I usually have a function called init BFS. So I would just say for and then I say layer. I initialize all the layer to okay, let's call them u, so that you see it's the index for a node. So set the layer to -1 and call scene u to be false. I haven't seen it yet. Okay, so something like that. Okay, so BFS starting from some vertex S. Okay, so now when you do the breadth first search, you need to maintain a list of nodes. Okay, the first is the list of nodes in the current layer. Okay, so we're gonna do this. Okay, say in the beginning you have this layer, so this is the current layer, and then you figure out the next layer here. Okay, so after you're done, this will be your current layer, and then you figure out the next layer. After you're done, this will be your current layer, and you are figuring out the next layer there. Okay, so I'm gonna keep two set of vertices, two lists, and as you can guess, I'm not gonna actually keep the list of vertices. I'm gonna keep them as a vector. So I would call vector int and say current layer and vector in next layer. Okay. Okay. So the idea is that I would initialize the current layer to be only S, right? And the layer of S will be 0, and I have seen S, right? So that's the starting point, and then I'll keep my loop iterating the whole loop. Okay, I'll break at some point. Okay, now in here I would just look at all nodes in current layer and figure out, find, add new nodes. These are the nodes that I haven't seen to the next layer. Okay, and then after this I would just when I'm done with this layer, I would basically move to the next layer. Okay, so let's call okay, so when I'm in, I would say I would copy the current layer to be next layer, something like that. Okay, and then I clear so that I'm ready to start the next loop. Okay, but however, if there's no next layer, that means when I'm at the end of my loop, then I should stop. So if next layer dot size equals 0, I mean no more vertices, then I just break out of this loop. Okay, so that's the idea. Okay, so now let's implement this loop. Okay, so I would basically iterate over all nodes in the current layer. So so let's do that. So for now, the current layer is a vector. If you want to iterate over all the elements inside a vector, you can use, if you recall from the previous video, you can use iterator. So you say vector int iterator. Okay, I equal current layer dot begin. Then I is not equal current layer dot end. Then I say I plus. So now I have my iterators that would iterate over the elements inside the vectors. If you want to get the actual value, so you can think of I as a pointer, right? So if you want to get the value, so let's call it u. So you need to copy dereference it. So this is the node in the current layer, and again you can say just auto here, so that would save your typing by a lot. So that's my code for iterate over all the layer. Okay, current layer. Now this is the part from the STL. Now you need to look at all the nodes that is adjacent to you, but what are the nodes that is adjacent to you? We kept it in this vector, if you recall. So it's in ADJ vector. So you need to iterate over all the ADJU, right? Iterate over nodes in ADJU. Okay, so you can do that in many ways, because we have the degree parameter, so we can do this pretty easily. So let's call d equals 0, d less degree u d plus. So that's the degree, that's the number of nodes adjacent to you. And then you say, so the vertex, the nodes v that is adjacent to you is in ADJ u d, right? So that's the dth guy in the list. Okay, so if you recall, this is the you look at ADJ 0, right? And now you look at ADJ 0 0, that would be this one, and ADJ 0 1, that would be 5, and you have degree of 0 to be 2. That's the idea. Okay, so that's how you look at the what is this. Okay, now this is the vertex, this is a node that is adjacent to you, but we're not going to add every node that is adjacent to you, because if you look at this example, you can see that from 1 it's is adjacent to 0 and 4 and 2, right? But 2 and 0 is already seen. Maybe 2 is not, right? But okay, when you add 0, you add 1 and 2. When you add 1, right, you see 0 and 2, right? But 1 is already seen, 2 is already seen, so you need to make sure to check that condition. Okay, so basically I would check if I have not seen v. That means that's a new vertex. Okay, when I see the new vertex, I just add it to the next layer and I mark it as seen. And I also knows that the layer of that vertex would be the next layer. So if layer of 1 is 1, the node that 1c should have layer 2. So I would say layer v equals layer u plus 1. Okay, this line is extremely important, and if you don't understand why I put it like that, you need to really go back and think about it. Okay, so that's the loop. That's the loop for so this look at all the nodes. Okay, and then I add new nodes to the next layer there. Okay. And then if there's no new nodes in the next layer, I break. Otherwise, I move the next layer to the current layer and then clear the next layer vector so that the next time I see new vertices, it works. Okay. Now, that's how it works. So let's try to run it. Okay. But before we run it, let's do this. Let's try to print something so that we see some output. Okay. Okay, so let's say when I look at the vertex here, so I put out this vertex U, visit U, layer equals layer of U. Okay, so that's the list of vertices. Wow, this log the vertex that the nodes that I actually visit in order. Okay, so let's try to run it with some example. Okay, let's try to compile it first. G++. So I'm compiled using a command line. If you use VS Code, it should be fine. Oh, okay. So my main should be int. Then I should return 0. Okay, so that's my code compile. So let's write one example for that input. Let's try this one. Okay, so basically okay, it starts with 0, but as you recall, we should start with 1. Okay, so let's write it. Let's try to increase it by 1. Okay, so so how many vertices that we have? 13, 14. So it's going to be 14 nodes. How many edges? 1, 2, 3, 13 edges. Okay, so let me increase everything by 1. So 0. So this 0 to 1, I just type in 1, 2 here. Okay, and then I'll do that really quickly. I hope I don't mess it up. That's this vertex. And 7, 5 is going to be 8. It's undirected, so it's going to 7, 5 is going to be 8, 6. I just can type 6, 8. Same thing. Okay. And then 4, 8 is going to be 5, 9. And 4, 6 is going to be 7, 5. So 7, 4 is going to be 7. 6, 4 is going to be 7, 5. Okay. And then the other, what is this? 9, 10, 11, right? So 9, 10 is going to be 10, 11. 9, 11 is going to be 10 and 12. And this one, 13, 14. Okay, so 14, 13. Let's do that. So that's the input. And let's run it. Okay. So it starts with 0. That's layer 1, right? That's layer 0. And then you're going to see 1 and 2. And this is the first 1 and 2 here. Okay. And then layer 2, we have 4, 5, 3, 7, right? So it's going to be this layer 2. And the last thing is going to be layer 3. So that's how our code works. You can see that it's the numbering starts with 0 because I changed it that way. Okay. Okay, if you want to count the number of connected component, you need to in your main, you need to not just call BFS once, right? You need to call it many times, but you need to call it at the vertices, at the nodes that you haven't seen, and you count the number of times you called it. Okay, so that's the hint for the connected component. Okay, so let's go over all the tasks in the grader really quickly so that you can start working on them. So there are a bunch of tasks. Okay, you should do it by the number. Okay, So concount, you should start with concount, B9, okay? And then you should try with jump point. In jump point, you need to, it's a graph problem, and you want to count the number of times you need to jump. So you need to construct a graph. And to construct a graph, you need to figure out what are the nodes and what are the edges. Okay, you can jump if you look at the task. So you have a trees, and you can only jump if the tree is not too far. Okay, so you need to calculate the distance between two nodes using the location here and add edges appropriately. And then if you want to count how many times you need to jump, is basically you need to call breadth first search to find the shortest path, and then you can solve this problem. Okay, quality map and continents and battleship is you can do it without actually build a graph, but the idea is basically it's like a graph. So you have a map like this, and you say it's on the same continent if you can travel on the graph like that. So you can look at this as a map, but you can traverse on the map if it's in 4 direction, up, north, east, west, south, something like that. You can build this as a graph problem. You can explicitly build a graph, or you can just write a code that work with the map as an array directly. And any way you like, you can try it. Continent is the same idea, okay? And battleship is the same idea, okay? Okay, for you have this bus problem. Again, bus is in bus task. You basically you wanna check if you can reach from one node to another node. There are constraints where you can move from one node to another node depending on the power of the bus and the height of the node. So read carefully. You can basically use breadth first search, but you need to make sure that you only take edges that are that satisfy the condition. Okay, so be careful. And the other two problems are optional, forward mail and roads, but everything you can solve everything with breadth first search, I think. Okay, maybe not with forward mail. If that's the case, I'm gonna, but I think you can actually solve it with breadth first search as well. If not, I would remark it as as a comment in Discord. Okay, so that's the task for today. I hope you have fun, and the TA will walk around so you can ask them questions, and they can certainly help you. Okay, the code that I write here, I'm gonna post the link to the code, but again, don't just copy. Okay, you should try to write it on your own, and then if you find a bug, then you can come back and look at the code that I have. Okay, and don't forget to remove this, otherwise your output will be incorrect. All right, good luck and have fun solving the problems.